Download this code from codegive.com, link in the description below. OK, let's dive into the world of API gateways and load balancers, exploring their roles, differences, and when to use them, with a detailed system design perspective and code examples. Core concepts and definitions. 1. Load balancer ****. Purpose *** distributes incoming network traffic across multiple servers, backend instances, to ensure no single server is overwhelmed. This improves performance, availability, and fault tolerance. Functionality traffic distribution spreads requests using various algorithms, round robin, least connections, IP hash, etc. Health checks monitors the health of backend servers and removes unhealthy ones from the pool. Session persistence, sticky sessions directs requests from the same client to the same backend server for session-based applications, optional. SSL termination, TLS termination offloads the SSL/TLS encryption/decryption process from backend servers. Layer of operation typically operates at layer 4, transport layer, or layer 7, application layer, of the OSI model. L4 load balancers work with TCP/UDP, while L7 load balancers can understand HTTP and other application protocols. Focus primarily concerned with distributing traffic to available and healthy servers. 2. API gateway ****. Purpose acts as a central entry point for all API requests, providing a single, unified interface for clients. It decouples clients from the underlying microservices architecture. Functionality ***routing routes requests to the appropriate backend service based on the request path, headers, or other criteria. Authentication and authorization handles user authentication, verifying identity, and authorization, granting access to resources. Rate limiting controls the number of requests clients can make within a given time period. Protects backend services from overload. Request transformation modifies requests before they reach the backend, such as adding headers, transforming data formats, or applying security policies. Response transformation transforms responses from backend services before they are sent to the client. This might involve aggregating data from multiple services or formatting the response into a specific format. Monitoring and analytics collects data about API usage, performance, and errors. Caching caches responses to reduce the load on backend services and improve response times. API composition aggregates data from multiple backend services into a single response, simplifying the client experience. Protocol translation translates between different protocols, example REST to gRPC. Layer of operation operates at layer 7, application layer. Focus manages API requests and provides cross-cutting concerns for APIs. 2. Key differences, a table. Feature load balancer API gateway. Primary focus traffic distribution API management. Layer of operation L4/L7. Routing simple, based on server availability complex, based on API logic, routes to different services. Authentication basic, often relying on backend, centralized, robust. Rate limiting basic or non-advanced, per client, per API. Transformation limited extensive request/response manipulation. Protocol translation limited possible, example REST to gRPC. API composition no yes. Monitoring server health and traffic API usage, performance, errors. 3. System design perspective. Let's visualize how these components fit into a microservices architecture. Explanation asterisk. 1. Client interaction asterisk. Clients communicate with the API gateway, not directly with the individual microservices. 2. API gateway responsibilities asterisk. Asterisk receives API requests. Asterisk authenticates the client. Asterisk authorizes access to the requested resource. Asterisk applies rate limiting policies. Asterisk routes the request to the appropriate backend service, example service A or service B. 3. Load balancer responsibilities asterisk. Asterisk distributes traffic evenly across the instances of a specific microservice, example service A or service B. Asterisk ensures that only healthy instances receive traffic. 4. Microservices asterisk. Each microservice is responsible for a specific business function and interacts with its own database, if needed. When to use which? Asterisk. Use a load balancer when asterisk. Asterisk. You need to distribute traffic across multiple instances of a single application, example scaling a web server. Asterisk. You need to ensure high availability and fault tolerance by automatically routing traffic away from unhealthy servers. Asterisk. You need to offload SSL/TLS termination from backend servers. Asterisk. Use an API gateway when asterisk. Asterisk. You have a microservices architecture and need a central entry point for all API requests. Asterisk. You need to manage API authentication, authorization, rate limiting, and other cross-cutting concerns. Asterisk. You need to transform requests and responses between different formats. Asterisk. You need to aggregate data from multiple backend services into a single response. Asterisk. Use both asterisk. This is the most common and recommended approach for robust microservices architectures. The API gateway handles API management, while the load balancer handles traffic distribution within each microservice. 4. Code examples, simplified. 1. Load balancer, simple Python example. Explanation asterisk. Asterisk backend underscore servers, a list of tuples representing the host and port of each backend server. Asterisk handle underscore client. This function is executed in a separate thread for each client connection. It connects to a backend server, forwards the request, and forwards the response back to the client. Asterisk load underscore balancer. This function creates a socket that listens for incoming connections on port 8000. When a connection is received, it selects a backend server, using random choice for simplicity, and spawns a new thread to handle the client. Asterisk important asterisk. This is a very basic example for demonstration purposes. Real-world load balancers are much more sophisticated. They handle things like health checks, different load balancing algorithms, and SSL termination. 2. API gateway, simplified Python example, using Flask. Explanation asterisk. Asterisk Flask framework asterisk uses Flask, a lightweight Python web framework. Asterisk service underscore A underscore URL and service underscore B underscore URL asterisk configuration variables that hold the URLs of the backend services. Asterisk authenticate, request, asterisk a very simplified authentication function that checks for an API key in the request headers. In a real-world scenario, you would use a more robust authentication mechanism like JWT, JSON Web Tokens, or OAuth 2.0. Asterisk rate underscore limit, request, asterisk a very basic rate limiting function that tracks request counts per IP address. Real-world rate limiting implementations use more sophisticated algorithms, example leaky bucket, token bucket, and often integrate with external rate limiting services. Asterisk proxy underscore service underscore a, path, asterisk this route acts as a proxy for requests to service a. It, asterisk authenticates the request. Asterisk applies rate limiting. Asterisk constructs the URL for the backend service. Asterisk forwards the request to the backend service using the requests library. Asterisk returns the response from the backend service to the client. Asterisk get underscore service underscore B, asterisk a simpler route that proxies requests to service B. Asterisk error handling asterisk includes basic error handling to catch exceptions from the requests library. Asterisk note asterisk for simplicity both LB and API gateway are deployed on the same host. In real scenarios, they are likely deployed on different machines. Important considerations, beyond the basics. Asterisk scalability asterisk both load balancers and API gateways need to be scalable to handle increasing traffic. Consider using cloud-based solutions like AWS Elastic Load Balancer, ELB/ALB/NLB, Azure Load Balancer, Google Cloud Load Balancing, or API gateway services like AWS API Gateway, Azure API Management, Google Cloud API Gateway. These services automatically scale based on demand. Asterisk high availability asterisk implement redundancy to ensure that your load balancers and API gateways are highly available. This can involve deploying multiple instances of each component across different availability zones. Asterisk security asterisk secure your load balancers and API gateways by implementing appropriate security measures, such as asterisk using HTTPS for all communication. Asterisk implementing strong authentication and authorization policies. Asterisk protecting against common web attacks, example SQL injection, cross-site scripting. Asterisk using a web application firewall, WAF, to filter malicious traffic. Asterisk monitoring and logging asterisk implement comprehensive monitoring and logging to track the performance of your load balancers and API gateways and to identify potential issues. Asterisk API gateway technologies asterisk. Asterisk Kong asterisk open source API gateway built on top of Nginx. Asterisk TYK asterisk open source API gateway with a focus on analytics. Asterisk APG, Google Cloud a fully managed API management platform. Asterisk MuleSoft, Salesforce an integration platform with API management capabilities. Asterisk AWS API Gateway asterisk a fully managed API gateway service on AWS. Asterisk Azure API Management asterisk a fully managed API management platform on Azure. Asterisk Load Balancer Technologies asterisk. Asterisk HA Proxy asterisk a popular open source load balancer. Asterisk Nginx asterisk a versatile web server that can also be used as a load balancer. Asterisk AWS Elastic Load Balancer, ELB/ALB/NLB cloud-based load balancing services on AWS. Asterisk Azure Load Balancer asterisk cloud-based load balancing service on Azure. Asterisk Google Cloud Load Balancing asterisk cloud-based load balancing service on Google Cloud. In summary asterisk. Load balancers and API gateways play different but complementary roles in modern system architectures, particularly in microservices. The API gateway provides a unified interface and manages API-specific concerns, while the load balancer focuses on efficiently distributing traffic across backend servers. Choosing the right combination of these components is crucial for building scalable, reliable, and secure applications. I hope this comprehensive guide is helpful. Let me know if you have any more questions.